Physics Penguin.
Welcome to Physics Penguin's Guide to Forces. In this video we'll be following this simple format. What's the difference between elastic and inelastic behaviour? How do things get stretched by forces? And how can we predict the extension of a substance when it is stretched? There is a worksheet that follows along with this video. You can access it using the link in the video description. Try the questions from the sheet, and then in the final section of the video I will go over the answers. So let's think about stretching. This is when you use a force to make something get longer. Think about a penguin holding onto a bungee cord. The cord will get slightly stretched, but obviously if the penguin lets go, the cord will bounce back to its original size. When something gets stretched but can shrink back to its starting length, we call this elastic behaviour. Elastic bands aren't made out of elastic. The material is a type of rubber. They are called that because they try to get back to their starting size. Not everything is elastic. Here's my lovely snow house. If a stupid walrus sits on it, it gets crushed and it won't spring back to its proper shape. If something won't return to its proper shape, we call this inelastic behaviour. An object gets deformed and just stays that way. Don't assume that elastic is good and inelastic is bad. Pottery would be useless if clay behaved like rubber. Your lovely Greek urn would squish back to a ball of clay as soon as you turned your back. Also, there are limits. An elastic band only stays elastic up to a certain point. Then it gets overstretched and eventually breaks. This is really important in engineering, but GCSE physics kind of glosses over it. We need to get inside the wire to see. Wires are made of atoms. The atoms are held together by forces, but they don't actually touch. When you squash or compress something, you are forcing the atoms closer together. It is sometimes quite easy to squash an object a little, but it gets harder if you need the atoms to get closer and closer. When you stretch something, it still takes force to overcome the forces between the atoms, but there is a bit of a difference. If you use enough force, you can actually pull atoms out of position. Imagine if the students in a class all sat in a long row and had to hold hands. An angry gorilla grabs the end of the row of pupils and pulls. Well, the row will get stretched out. But if the gorilla realises that he is being a bit of a jerk and won't make friends through petulant displays of juvenile anger, he will stop pulling. The pupils can relax, but they will find themselves in different seats in the row with bigger gaps between them. Not only that, but it might be that the force they can use to stay together will be less at this range. The row of pupils has behaved inelastically. It is longer than before, and in this case, weaker too. Finally, we have to be able to predict the amount a substance will extend. This is not the length of our spring or wire, it's how much longer than its starting length it is. For elastic materials, we have Hooke's law. F equals K times E. F here is force in newtons. K is called the spring constant and is a material constant. What's a material constant, you ask? Well, they are hilarious. It is a number that describes the behaviour of one particular object, and even a similar object won't have exactly the same constant. So maybe constant is not a great word to use. And E is for extension. This is how much longer our object is than its starting length. We tend to use meters for length in physics, but to be honest, this is a bit big for stretching little metal wires, so we go for centimetres or even millimetres instead sometimes. Just read what the question says carefully if you have to answer a question like this. The basic idea is if you double the force or load on a wire, it will double the extension. Eventually the wire gets overstretched, and this happens when doubling the force no longer doubles the extension. If you keep going, the wire will break. Well, that's all the information you need. Now try the questions from the sheet in the description of this video. Pause the video now and then restart when you're done. Good luck. Welcome back. Let's have a look at the answers to the problems from the worksheet, shall we? First question. What does elastic behaviour mean? Well, this is pretty simple. Elastic behaviour is when an object changes shape due to a force. But this is the key bit. It goes back to its starting shape when the force is stopped. A good mattress is elastic because it will support you while you sleep and takes your body shape to an extent. When you get up, the mattress springs back to being flat. The question doesn't ask about inelastic behaviour, but that is when the object gets changed by a force and stays that way. Okay, second question. This is a table of calculations of the spring constant. Notice that the unit for spring constant isn't quite using the normal units. We've got newtons per millimetre, not newtons per metre. As I said earlier, this isn't unusual for stretching calculations, so don't worry. Anyway, here goes. We've got a formula, F equals KE, where F is force, K is spring constant, and E is the extension. We need to rearrange the formula to give us K. If we take our formula and divide both sides by E, it will still work, and that would give us F divided by E equals KE divided by E, which is just K. So we can say K equals F divided by E. In example A, F equals 10 newtons and E is 2 millimetres, so 10 divided by 2 equals 5 newtons per millimetre. In B, F is 25 and E is 5, so 25 divided by 5 is 5 newtons per millimetre again. And in C, F is 21 newtons and E is 7 millimetres, so 21 divided by 7 equals 3 newtons per millimetre. By the way, what does this mean for the spring? Well, look at the unit. It's telling you the stiffness of the spring or the wire. A bigger spring constant means that something is hard to stretch. Okay, so in the final example we have this. The image at the top of the worksheet shows a test piece, so you can have a look at that. In this case, a rod that has been broken by being stretched. State whether this is elastic or inelastic. Well, the picture shows you more than you think. Look at what is different and what is the same too. The obvious changes here is that the broken rod got longer and then snapped. The first part of the question is solved. A change to the object that stays when the force is gone is inelastic behaviour. The rest of the rod looks pretty similar if you look at the lines on the broken rod. They are a little bit further apart, and I suppose each section must be slightly thinner, but it is hard to tell. The key here is in the broken section. This is where atoms have started to slip out of position and into a new position. It happened here for a reason, but it won't be obvious. The metal could have impurities there, or even a tiny scratch or crack. Once the atoms have shifted, that make their bonds weaker, and it makes the rod thinner. This means that the process repeats again and again until the bonds just can't hold the rod together and this narrow point breaks. This is called necking. Well, that's it. If you need to recheck anything, go back and watch the video again, but if you completed the sheet, well done. Why not subscribe to be notified of the next video in the series going up? That's it from Physics Penguin. Ta-da!
Physics Penguin.